Alright, and welcome to Non-Factorable Inequalities. Now in example 1, we see f of x is greater than or equal to x squared plus 8x minus 3. Of course, our very first step is to always rewrite the f of x as a 0. We always want to set our quadratics equal to 0. And then we have x squared plus 8x minus 3. Now, we see here that our a value, we see that a is equal to 1, check. So we want to try simple factoring. Now the question then becomes, can we break up negative 3 into two numbers that will multiply to be negative 3 but will add up to be a positive 8, or in other words, our b term? Well guys, let me ask you this. What are the factors of 3? There's only two options. There's 1 and 3. And in this case, since it's a negative, one of them has to be negative, one has to be positive. There's no way that those can ever get us to a positive 8. So what does this tell us? It tells us that this equation is essentially non-factorable. So here's what we're going to do. We are going to first, I always want you to flip these quadratic inequalities so that our actual function is on the left. So I'll rewrite this as x squared plus 8x minus 3. And my inequality of greater than or equal to will flip to become less than or equal to 0. The next thing that we want to do is we want to label our a term, our b term, and our c term. So I can see that a is clearly 1, b is clearly positive 8, and c is clearly negative 3. Now from there, what we want to do is we want to use the quadratic formula. If you wanted to complete the square on this, you surely could, but I think the quadratic formula is the best way to solve non-factorable quadratics or inequalities. So let's write out the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And remember, what's our very first step? Well, we always want to change our letters into sets of parentheses. So I'll write negative parentheses plus or minus the square root of parentheses squared minus 4 parentheses parentheses all over 2 parentheses. And let's go ahead and plug in all of our numbers. We know everywhere we see an a, let's see, there's a and there's a, we're going to plug in a positive 1 and 1. Okay, let's see, everywhere where we see a b, we're going to plug in a positive 8. So there's a b, there's a b. So I write in 8 and I write in 8. And lastly, everywhere where we see a c, we'll plug in a negative 3. Notice there's only one c term, and it's at the very end inside the square root. Now from here, I kind of gave you all a rule. I said we'll always simplify the outside. A negative times a positive is a negative plus or minus the square root of. We know that 8 squared, we're going to now simplify the inside, where 8 squared is 64. The next thing I always want y'all to do is to count the number of negatives. I see one negative, two negatives. Two negatives make a positive. And here, 4 times 1 is 4, and 4 times 3 is 12, all over. Now we simplify the bottom, 2 times 1, which is 2. And guys, I'm sorry for cramping that in there for y'all. Now from here, what do we know? Well, here we actually have to simplify the inside of the square root one more time. So now we have negative 8 plus or minus the square root of 64 plus 12, which will in fact give us 76 all over 2. Now, what would I do if I were y'all here? Well, the next thing we want to do is find out what in the world, I'll switch back to this nice screen, is the square root of 76. And the square root of 76 is 8.7. Let's just go that far. Now here's what we're going to do. We're going to split this up into two things. We're going to write x equals negative 8 plus the square root of 76, or plus 8.7, let's go one more, 8.72, all divided by 2, comma, and here we'll write out again negative 8, but in this case, our second one, we're actually going to include the negative 8.72 all over 2. And once we solve these, we're actually going to have our two x-intercepts. Now I would encourage y'all to pause the video because I'm going to have to erase some things so I have room to write. So everybody pause the video and let me clean this up just a little bit. Okay, now here I've moved this up to the top and I know that I have this. X equals negative 8 plus 8.72. I would encourage you to use your calculator for this. Will be 0.72 all divided by 2, comma, and here negative 8 minus 8.72 will actually give us negative 16.72 all over 2. And we can now finish this off by getting our solutions. 0.72 divided by 2 will give us, of course, 0.36, comma, and negative 16.72 divided by 2 will give us negative 8.36. And from here, now that I have my two x-intercepts, we can go on to solve the problem. So remember, those are my x-intercepts, or we could call them our solutions, or we could call them our roots, or we could, of course, call them our zeros. They have those four separate names. And so I go draw my number line, and off to the left here I'll have negative 8.36 because it's the larger negative number, it goes to the left. And over here I have 0.36. Now, this one is kind of rough because there's no clear, nice, easy factors, but let's still use our little trick from last time. I know that x equals 0 is always in between a negative and a positive number. So I know that right now, x equals 0 is in this middle region. And what am I going to do? Well, I want to show you all kind of this shortcut. X squared, we're going to take this inequality right here, and we'll say x squared plus 8x minus 3 is less than 0. Remember, we're looking for all of our negative solutions when our function is less than or equal to 0. And when I plug in the value of 0 that I was searching for, well, 0 squared is 0. It's gone. 8 times 0 is 0. It's gone. And check it out. All we have left over is a negative. That means everything in this middle region is a negative solution. And because we're going to have multiplicities of 1, that means that once we hit this value, we know that the next region must have all positive solutions. It's going to switch. And because we have this here, a multiplicity of 1, when we go over to the next region, it also switches from a negative to a positive. So the question becomes, in what region are my solutions? And remember, we said here we are looking at where the function is less than or equal to 0. That's all of our negative solutions. So our solutions are going to be right here. The last thing we need to do, since it's less than or equal to, when we circle these, we have to shade them in. And when I circle this, I have to shade it in. And we know when our solutions are in between two numbers, it's a conjunction of solutions. So how are we going to write our conjunction of solutions? Well, we're going to say basically this. When it's a conjunction of solutions, we're going to say that our leftmost value is negative 8.36 is less than or equal to x is less than or equal to 0.36. And notice I have to use the less than or equal to symbols because in our original function there, those are there's an equal to symbol there as well. Okay? And so that's the correct answer. In fact, let me write it one more time, very nice and neat. Negative 8.36 is less than or equal to x is less than or equal to 0.36. Okay, let's go ahead and do one more example. All right, here we go. It's Mr. Hastings' final question of the pre-Christmas semester. So let's take a look at this quadratic inequality. We see here that it is 5x squared plus 8x is less than 3x plus 2. Now in this case, there's we have to get it equal. We have to get one side equal to 0. In this case, I would suggest moving the things on the right since I want 0 to be on the right. So we will subtract 3x and we'll subtract 2. And over here, I will subtract 3x from my x value and I will also subtract 2. And notice that is a 0 pair, that is a 0 pair, and we can simply write this as 5x squared. 8x minus 3x is plus 5x minus 2. and we'd say that that is less than 0. Now you'll notice something. Our a value, a is not equal to 1, and since a is not equal to 1 and 5 is not the GCF, we know negative 2 can't be divided by 5, there's a good chance that this is unfactorable. We could try to use factoring by grouping. However, I'm going to give you all some spoilers. This is not factorable. So what are we going to say? Well, we're going to label our a term, our b term, and our c term. And we know that our a term is 5, our b term is 5, and our c term is negative 2. And here, we're going to go ahead and use the quadratic formula. I'm going to use different colors here so we can really distinguish. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you don't have the lettering here, what I would suggest is you should have written this down from our previous example. I'm just diving straight into it. Alright, so what are we going to have? Well, we know that everywhere we have our b terms, these are where my b terms are, I'm going to put in a 5. I know that where my a term is, I'm going to put in a 5. And where my c term is, I put in a negative 2. And where my a term is, I put in a 5. Okay, and now we get to start simplifying. On my outside, a negative times a positive is a negative 5 plus or minus the square root of. I know that on the inside, 5 squared is 25. And here I count up my negatives. 1, 2, a negative times a negative is a positive. And y'all should know this off the top of your head. 4 times 5 is 20, but what is 20 times 2? Well, that will be 40. All over 2 times 5, which is 10. Now, when I simplify my inside one more time, I have negative 5 plus or minus the square root of. 25 plus 40 will be 65, all over 10. And from here, I can actually create my two solutions. I can say that x is equal to negative 5, and I would encourage y'all to grab your calculator. And what is the square root of 65? Well, we're going to write plus 8.06 all divided by 10. And you know what? Here's what I'll do. I'll even drop down here. We'll say x equals negative 5 minus, because remember it's plus or minus the square root of 65, minus 8.06 all over 10. And once I determine what these two things are, I am going to have my solution. Now, this has gotten a little bit messy, a little bit sloppy, so what I'm going to do is pause the video, clean everything up, and I want y'all to finish taking your notes up to this point. Okay, so I rewrote these two solutions that we're still searching for, and now I can write x equals, what is negative 5 plus 8.06? Well, that's going to be 3.06 divided by 16, comma. Over here, we'll have x is equal to negative 5 minus 8.06, so negative 5 minus 8.06 will give us negative 13.06, all divided by, oh, I'm sorry, that's not a 16, that is a 10, that I just wrote kind of sloppy, that's a 10, and from there, well, that's pretty easy. When you divide anything by 10, you're always moving your decimal one place to the left. We'd say this is 0.3, and you know, let's round that 6, let's take that 6 and round the 0 up to a 1, comma, and here, if I move the decimal one place to the left, I get negative 1.3, and I'll take this 6 and round that 0 up to a 1, and there are my two x-intercepts. Now, one more time, I'm going to pause this video. I'm going to kind of clean things up. But before I do that, let's just kind of take a look here. What are we saying? We're saying if I draw my number line, my negative value goes on the left, negative 1.31. My positive value, 0.31, goes on over here. And we're going to circle those 2 points of interest. Okay, y'all, pause this, finish taking your notes, and we're about to finish this. Okay, so we have 5x squared plus 5x minus 2 is less than 0. And we've drawn our number line with our two x-intercepts, and we're trying to find the region where all of our solutions are. So the first thing to note is that this is saying the function is less than 0 we are looking for our negative solutions. We come down to the number line and we want to find out, where does x equal 0? Notice x will always equal 0 in between our negative solution and our positive solution. And so what happens when I plug 0 into my equation? I get 5 times 0 squared plus 5 times 0 minus 2 is less than 0. And y'all are going to notice when I plug in 0 here, that goes away because 0 squared is 0 times 5 is 0. And here 5 times 0 is still 0. And we have a negative. So my negative solutions are in the middle region. Now when I hit this guy right here, it's going to switch to being a positive solution, and going the opposite direction, my negative solutions switch to positive solutions. Now from there, since we're looking for everything that is less than 0, or our negative solutions, we are looking for everything in between these two regions. Notice, since this is less than, we cannot include these two values so they stay as open circles. And so what does our answer look like? We would say that our answer is going to be this. Negative 1.31 is less than x is less than 0.31. All right? Well, y'all, I know that this was tough. I know that these were 2 long videos, but sometimes math gets hard, and I need you guys to step up. If you don't know, you got to reach out. You got to come to tutoring. All right? I'll catch you guys in a little bit.